Hi. Last week we had a look at a bit of Maker Tech, and specifically we came across this little M5 stack Atom device. A really cool way of getting up and running fast. It's got USB-C in the bottom, and you can just plug in essentially breadboard pins straight into the top. Now the whole theme of this was getting off the breadboard and into production as fast as we could with some form of makery project, connecting a sensor or controlling a relay. So let's see how fast we can get up and running with that today. Now at some point we're going to have to put code and logic on this thing. But the quickest way to write code is to not write it at all, and that's going to be the theme of what we look at. Now, I'm a big fan of Home Assistant. This is what our Home Assistant instance looks like running on the property. We've got tons of information coming out here, and we could probably do some work on our UI layout, but it's super powerful. We've got information about ventilation in the roof, controlling different lights. We can see heat moving around the property for hydronic heating, for solar hot water. We can control whether the house water is even turned on or off. We've got different levels of automation around the hot water system. So here it's currently on, we can see the target temperature, control the thermostat, and there's actually a manual override that's been applied. We can see the water flow in terms of when the house water pump's running, hour by hour, how much water we're using, different hours of the day, how much water we used yesterday as an aggregate, 414 litres for the day. Information about humidity drainage, it's all amazing, but it comes from lots and lots of different sensors and controls across the property. And what Home Assistant gives us is this single kind of ability to bring it all together, and then it automatically deals with, there's mobile apps, there's Google Home integration, Alexa, HomeKit, there's widgets for the home screen of your phone, you can get Apple Watch stuff, it's all kind of there done for you already. What's great about it is that there's 1,600 plus integrations already pre-built. There's literally thousands of these things. So we've got an automation layer, we've got a UI, but sometimes it's a little bit hard to find exactly what we want. And to give one example of that, if I jump across to our climate screen here, where we're pulling in all sorts of different temperature information and stuff like that, we're also now going and tracking some of the air quality in terms of the particulate matter on the property. Now, that's something we're going and finding an air quality sensor that we can run locally on the network, that we can bring into Home Assistant. It was a little bit hard, so let's just go and build it. And those are the types of scenarios that you want to make as easy as possible, and where something like little M5 comes in. So today, we want to go and build one of those. Now I'm going to jump across to a different instance of Home Assistant. This is just the one in my apartment, just because it's a little bit more of a clean dev instance for me to work with, and there's less things pre-set up. The first thing I'm going to do is jump down to the supervisor here. So you should have this option on the left if you're running Home Assistant OS. If you don't have it, you're probably running Home Assistant Core, and I highly recommend you jump across to the OS version. There's two add-ons that I've got installed here, Samba Share and ESP Home, and I can just get those from the add-on store. Now add-ons here are basically just little Docker containers. You hit install and it deals with all the magic and brings them up in the UI. Pretty simple. I'm going to jump into ESP Home. Now, this is a project that's really specifically focused on programming ESP devices for Home Assistant. That's its whole role in life. Now, I don't have a node at all yet. I'm just going to come down and hit the little plus button here, and I'm going to run through this wizard. So begin, and I'm just going to call this demo 2, so I don't hit a conflict with any previous naming, and I'm going to choose the device type. Now, ESP Home works with ESP8266 and ESP32 based chipsets. There's lots of different boards out there. And what this is basically asking you is, hey, make sure you get the right processor, but choose the board that's most closely aligned to the one that you're using, because that gives it a little bit of information about things like the pin configuration, and for some of the 8266s, how much RAM they've got attached and things like that. Now, even though this is an Atom Lite, I'm going to choose the M5 stack core. Now I want this thing to connect to my Wi-Fi. I'm just going to type in a dummy 123.123 here for now, and you'll see me replace that in a second, because I don't need to type my Wi-Fi creds in, and also you want to manage these in a slightly more secure way. And then it's asking for this OTA access password. And this is a shared secret that we'll use for how do we log into this thing, do over-the-air updates over the network, and it's just the shared secret for that trust. Now again, I'm just going to type 123 in here for now, and I'll show you how we deal with that in a second. I hit next and hey, voila, we're done. Submit. Now, what gets created for me here is I've now got this node showing up, and it's got a red bar across the top, and it says demo2.yaml. So I can do a lot in this interface, but what I'm going to do is, because I've also got that Samba add-on installed, is just head to whack Home Assistant whack config, and I can see the underlying files behind Home Assistant. There's a folder here, ESP Home, And hey, there's demo2.yaml. It's the one we just created with the wizard. But the best place to edit that's going to be Visual Studio Code. So let's do a bit of work in here. If I look at, if I refresh that, demo2.yaml, this is what it's gone and created from that wizard. So it's saying, hey, ESP home, there's the name of the node, the platform, the board type, our Wi-Fi details. If it can't find this Wi-Fi, it'll automatically, after a minute, flip into broadcasting its own little fallback hotspot so that you can log in and configure it. And that's those details. And then there's some stuff set up around just logging, the API to talk back to Home Assistant, there's that shared secret, and supporting over-the-air updates. Now what this file is starting to do is to declaratively lay out what is the capability that we want on this device. So it says, I want you to connect to Wi-Fi, I want you to support over-the-air updates. So let's get a little bit more config in here. Now I don't want to go and have my Wi-Fi SSID and password in here, but what I can do is just type bang secret and then Wi-Fi _ SSID. And this type of key, if I do that for the Wi-Fi password as well, Wi-Fi password, I can then go and start to store this information in secrets.yaml instead. So I'm not going and littering it through each of the different config files. And what I could do in here is just go Wi-Fi SSID, my Wi-Fi name. In this case, just to make it a bit easier, I'm actually just passing off and importing another file. Just so I don't have to show all my details on screen and I have one shared file across my whole Home Assistant instance. So, hit save on that. So I've gone and passed off those details. I'm just going to leave that fallback API, fallback access point there for the time being. And then for this password down the bottom here, I'm going to use secret, and I have it just an ESP home secret, which is my shared secret for all of my ESP home stuff on the network. And that's just a long set of letters and numbers and stuff that I generated from a password generator. Now, what I actually want to do with this device to get it up and running is on the M5, there's a little LED on the top of it. And I want to just control that LED. Best place to start with IoT, make a light flash. And if I scroll down here into the specs, it says RGB LED WS2812B. Okay. Now what that is because it's not just a little LED that just turns on or off, it's actually red, green, blue. It's basically a screen with 1 pixel and a data wire that controls it. So I'm just going to take that chipset number and I'm going to go to the ESP Home website, esphome.io. And what this does is it shows all the different types of devices that it can generate firmware for. Stacks of stuff. But right now I want to control that LED. I'm just going to search for that chipset and it says, hey, it's a fast LED. Cool. And here it gives me a little block of code for how this works. Little block of YAML. I'm just going to go and copy that. It's all pretty well documented in terms of the different properties, chipsets, all sorts of things it supports. There's a little bit of electronics knowledge in here. But I'm just going to go and copy and paste that code in here. So I'm saying I want to set up a Lite. It's a fast LED clockless in terms of how it's controlled. The chipset is a WS2812B, was what it said on the Doco site, and what is in the supported chipsets here. The pin number is actually documented on the ESP itself, sorry, on the M5. It's got a little Doco panel here, and it actually says like LED is G27. So I'm just going to set it to pin GPIO 27, or you can even go shorter and just say 27. It's one LED, and just via a little bit of trial and error, I know it's a GRB, as in green, red, blue are the channels. And I'll just leave that as light for the time being. Now, I need to get this into firmware that I can run on this device. So I've saved that YAML file, and now I'm going to go back to the ESP Home web interface. And I'm going to go to the little kebab menu top right here and hit compile. Now, what this is doing is in that Docker container, which is both running this web interface and a few other things, is it's going and downloading all of the different dependent libraries it needs. So it's getting Arduino stuff, it's getting ESP toolchains, it's getting the dependencies for controlling the library for the fast LED, DNS server stuff, and it's going and taking that YAML file, getting all those dependencies, it's generating a set of C++ files, and then it's compiling them for me. So that ESP home container is basically like a little code generator and build server all in one. And for me, this is actually running on an Intel NUC just somewhere else in the house. It's not even running on my laptop. While that's all running, if I go back to VS Code and refresh here, I can see there's this demo2 folder has shown up. Now, I never need to go in that, but if we have a little sneaky peek and look at source, you can see all of this C++ code getting laid out here, where it's going and doing stuff like registering the Lite and all this kind of stuff. And behind it is stacks and stacks of code that it's gone and generated for us that we just haven't had to write. And it's busy going and compiling that into firmware. So let's back out of there, scary C++, don't need to look. Oop, minimize. And we'll just wait for this compile to finish. Now, as that generates that firmware, somehow we're going to have to get it onto this device. So I'm going to click the little question mark button down the bottom here for help. It's going to pop up a doco page. And in here, it's got a link to this tool, esphome-flasher. I'm going to head to that. It's going to take me to GitHub. And there's the releases on the side here. Now, there's lots of different ways you can flash an ESP device. If you've got any of them that work for you, you can stick with that. But if you've never done that, just grab this tool. As of August 2020, I've had a few problems with the speed changes they've been doing here in these later versions. So I'm actually going to go back and grab version 1.1. Works most reliably for me. I'm going to download the Windows executable. Nothing like getting random exes off the internet. Don't worry, it doesn't require admin elevation at all. But because it's a random executable off the internet, it will give you a whole bunch of warnings in your browser. So I need to keep the file, I need to show more, keep anyway, and hey, it'll release the file. Now, if you don't want to do that, you can go and get the ESP tool Python module as well, but I just like nice executables randomly off the internet. It makes Troy Hunt twitch. So come back here and chug, it's still compiling. There we go, linking. While that happens, I'm just going to take that chipset and I'm going to plug in a USB-C cable into my computer. And I'm going to open this flashing tool. More warnings. Don't worry, still have not done a UAC elevation on my machine. Hey, there's the tool, high quality Windows UI. Now, this has successfully compiled my code, and down here I'm going to say download binary. Okay, that's downloaded a demo2.bin file down here. And what I'm going to do is, with this plugged in, it shows up as a COM port. And I'm just going to go to C, users, tatha, demo2.bin, and say flash ESP. Now that's gone and detected the chip type, and it puts it into flashing mode. It's erasing the current flash that's on there, and now it's writing the coding. A little bit slow, you're talking like 115,000 bits per second, 115 kilobits per second of the flashing rate. And then it does this weird thing sometimes where new lines get confused and it deletes back on itself. But it's fine, it's flashing. So that's currently programming into here. And as soon as that finishes flashing, it will then automatically reset the chipset and start booting up that firmware that we've pushed onto it. Okay, so flashing is complete and it's running up some logs. It started a Wi-Fi scan and it's going and connecting to stuff. Now straight away in ESP Home, this bar here has come up green because it can now detect this node that's on the network. And if I jump into a command line, and if I just go ping demo2.local, that goes and does an MDNS or a bonjour query and finds it. And it's got an IP address on the network. So bam, it's on the Wi-Fi, it's connected, it's talking MDNS, it's a thing. And in here, I can go and hit logs, and I can remotely get logs off it as well. And I can see the Wi-Fi connection and all that. So that's pretty cool. Okay, so at this point, we can see logs coming out of it, but how do we actually control it? Now, the other thing that's shown up bottom left here in Home Assistant is this notification, which says, hey, it discovered a new device on the network, because the firmware in this is already smart enough to go out and broadcast a whole bunch of UPnP type stuff to say, I exist, and Home Assistant can pick that up. So I'm just going to say, check it out, and it says, oh, hey, I found let's ignore that one. I found this ESP Home Demo 2, do you want to configure it? Sure. Submit, and now it's asking for that shared secret that we configured. So this is the one here behind ESP Home secret. So I'm just going to go and grab that secret of mine and paste it into here. and it's gone and getting ready to configure it. And I can just click finish. Now, in this integrations page, I've now got demo 2 showing in this ESP home tile. And if I click into this, I can see one device and one entity. Go into the device, there it is, and I can see my light. And if I click on here, whoops, if I just turn it on, I get a white light, turn it off, turns off. If I click into the light, go to the entity panel, I can turn it on, and because it's a fast LED, I can actually go and control the colors of it even. I can go and it's red, I can go and make it green, I can put the brightness down to 50%, I can turn it on, I can turn it off. So it's a pretty complex set of UI that's up and running there, controlling a RGB multicolor LED with all of this like fine color control over the network, super low latency, that's already up and running. That's pretty cool. Let's go and add some more capability to it though. So I'm just gonna go back to my VS Code instance and start to add some more capability and clean this up a little bit. So the next thing I want to do is on the M5 itself, there's a little button on it. You can click this button. So let's start to bring that in. Now to do this, let's just keep copy pasting code. On the ESP home site, it's a sensor, and there's a whole stack of different sensors, but specifically just a binary sensor because it's on or off. And it's a binary sensor on a GPIO, because all it is just somebody pressing a button, and it's just one of those general purpose pins. And you can see the block of code here that goes and makes that work for us. I'm just going to copy that. So it's a binary sensor, GPIO. The pin, again, is documented on this little doco panel. So it's pin 39. I'm just going to remove that. I'll explain that later. Now, the other thing with this button, you'd find out if you ran all the code through and you'd be like, why is it in reverse? Is that when you press it, it sets it to low as opposed to setting it to high. So what I can also do here is just expand this pin and say pin number 39 inverted is true. While I'm in here, we're also starting to get this kind of name duplicating out a little bit. So I want to extract that. I'm going to put a new block at the top. Substitutions, spelling is hard, device name demo 2, and I'll do a friendly name demo 2, and then I can start to flow this through my code instead. And this makes it a lot more reusable when we go and have like multiple of these devices laid out around the house. So maybe we're building multiple temperature sensors and we want them all to work the same. I'm not going to bother with a password on the fallback Wi-Fi. It's in my house. Good luck. And down here, we can do the friendly name Lite. And for the button, I'll do friendly name button. Pretty cool. I've added some new logic there. And if I save that and I go back to the ESP home web interface, then what I can do here is instead of going under that kind of kebab off to the side and hitting compile, it's got this over-the-air update option. I can just hit upload. And that's going to compile our new code, and then it'll actually do an over-the-air update to this thing straight over the Wi-Fi. And what I like to do is do the very first flash as an interactive flash via USB, but then try to do as much as I can with over-the-air updates, because that helps me build confidence that the over-the-air updating will work, and then I'm not going to go and bust it up in some way, so that when I go and then bury this in a wall or a ceiling or under the house or something like that, that I'm not worried about doing those over-the-air updates. If you're running Home Assistant on something like a Raspberry Pi or something like that, and you're plugging the chipset directly into the Pi, you might also get an option up here top right to use that serial port so you can flash from ESP Home and stuff, but I find that a bit confusing. I like to just download the binary, do it on my local laptop, and then do over-the-air updates after that. So I'll just wait for that to compile. So that's compiled, and it's now uploading it over the network. And this is actually faster than doing it locally based on that like super slow serial interface it has. We've successfully done the over-the-air update. It then takes a little bit of time just for the chipset to boot up and then for ESP Home to find it again, and then it will start streaming the log output out of it. There we go, we've got the logs back and we're up and running. Now I don't need to re-adopt this at all into Home Assistant. If I just go back to Home Assistant configuration, integrations, demo 2, you can see one device now has multiple entities. The old entity there is because I renamed it, and I'll show you how to clean this up a bit later. But for now, I've got the button and the light. And if I look at the button, it's unfilled and it says off. When I hold that in, it says on, let go, off. You can see it's super low latency. That's because the API integration it's doing is some kind of like protocol buffer type thing, which maintains a really fast, persistent connection. And if I go into the light, I still have all of my same controls there to go and turn that on and do the colors and all that kind of stuff. So I've done an over-the-air update there of adding functionality in that goes and exposes that straight through to Home Assistant. Pretty cool. Now, that's all well and good just turning a light on and off and detecting a switch, but where this ESP Home stuff gets really cool is that there's stacks of other libraries that come into it. So for example, where I'm dealing with lights, I can come in here and just add in different effects. I want to be able to support random, I want to be able to support flicker, maybe for my Christmas lights. I want to do an addressable rainbow. So this is where you've got a string of addressable LEDs, like this fast LED stuff. You can have it like moving a rainbow along it. So I can configure effects like that. And what I can also do is do a little bit of automation directly here on the device itself. So what I want to do is when you press the button, I want to have the LED toggle on and off. And I want that logic to run on here, regardless of whether my Wi-Fi is up and regardless of whether Home Assistant is running. So to do that, on the light component, I'm just going to, as opposed to that friendly name, also give it an ID to refer to locally. And I'm just going to call that status LED. And then on the button, I'm going to start to add a little bit of automation in here. So I'm going to say on the button, when it's pressed, then, and that's because there could be a conditional before it, I want to take the light. I want to toggle a light, which is status LED. Really simple bit of logic, but we've got lighting effects going on and we've got automated controls happening here as well. I'm going to kick off an upload of that. Now, while it's compiling, I'm actually just going to rip out that power cable. And just to show that this is running totally independently, I'm going to go and power this up just on a basic battery pack, so freehand battery pack. You can see it actually comes up in the default state straight away. It's even smart about remembering the last state that it was in, for example. Okay, so that's done the over-the-air update onto here now. And if I go back and look at the device, I can see my button and my light still, and I can come in here and I can go and change this to any color I want. I can make it green, blue, purple. I can control the brightness, all those kinds of things. That still works. And I've got the button here. Now, what I'm going to do is as I press the button, the light turns off each time I toggle it. Now I'm still seeing the button status get reported out when I hold it there. And if I come out of here, when I turn it on, I can see the light turn on and I can see the light turn off. So that's now got localized logic running on the chip. That's totally disconnected from my computer over Wi-Fi and super low latency going and reporting that information back to Home Assistant. So nice little balance of being able to combine all those ideas together. And to show some of those effects, if I come back here and turn the light on, I can do something like that effect of rainbow. And the light there is now going and just cycling through all those different pretty little colors, which all of that code is just written for us, which is pretty cool. Now, to give you an idea of some of the kind of more complex, well, not even more complex, but sort of useful things you can do with it. A project I did the other week was to take my very 90s style intercom, the old handset on the wall you have to lift up and press the door release button, and I put one of the little ESP01 chips in there. And this was the YAML file for it. So I have an intercom set up, that kind of generic boilerplate. It's a different chipset and a different board that I needed to configure, but otherwise the same kind of Wi-Fi details. I then here actually expose an uptime sensor. So this just reports back how many seconds it's been booted up for, and a Wi-Fi signal sensor so I can see how good the connection is. I have the switch to hit the gate latch. I give it a name. I actually also give it an icon. So this type of metadata will flow from the device all the way back over that API connection back into Home Assistant and automatically set up the UI nicely for me. I have logic in here that when you hit the gate release, wait 10 seconds and then just automatically turn it back off. And I also have the detection of whether the gate's being buzzed or not, like if somebody's standing at the front door holding the button. And for that buzzer, I automatically hold for 250 milliseconds before I release it, just to remove any bounce effect on the button. So there's some pretty complex logic in there that's played out in kind of 60 lines of YAML, but really 30 lines of its boilerplate that runs on this little device and is over-the-air updatable. And the experience of that is, if I come onto the home screen here, I've got this gate latch, there's the icon coming through. If I hit that after 10 seconds, the device at the other end will automatically switch that back off and it reports the state back through to here. So it's all consistent end to end. I can then go and build automations like having the gate mode on auto or manual that automatically does stuff like send push notifications to my phone and stuff like that. So it's a really nice balance of how all that gets integrated. Other things that we've been building out is if I go back to the ESP homepage here, if I look for AS3935, we've got these little lightning sensors. It's tiny, it's a Franklin lightning sensor with a little block of YAML like that. You can integrate that with an M5 and you've got a localized lightning sensor. Or we're also we've done stuff like taken an SDS011, which is this particulate matter sensor, and that's how we're going and reading the air quality and representing it back here on the farm as well. So that's pretty cool. So that's for all the types of devices that Home Assistant supports out of the box. They've gone and dealt with all of these different wire level protocols that you might need to care about, which is pretty cool. But there's also some higher level concepts here. So where you've got something like a cover. Now a cover might be a pool cover or a garage door or a window blind, anything that covers something else. There's these pre-built concepts of a time-based cover and an end-stop cover. So if I look at this, if I go to the time-based one, here you can go and create a cover in ESP Home and say, hey, to open it, like to open the garage door, switch this on. It takes 2.1 minutes to open, and then to close it, switch this, and it takes 2 minutes to close. And to stop, do this. And just with that little bit of logic there, Home Assistant will then automatically render that as this nice bit of UI of, I want to raise the garage door, stop its movement, or lower it, or drag it to a position that's estimated based on the time. Alternatively, if we have active sensors for when it reaches the ends and it needs to stop, there's also an end stop cover where I can go and declare those different sensors that trigger that. So all of that logic there about, okay, I want to run for a minute and then stop to reach the halfway position, all of that's dealt with for you, all nice and done. Now, what are the competing options? The other one that's out there is Tasmota, is reasonably popular. This is open source firmware for ESP8266 devices, so it's a little bit old, and it's really focused around exposing them as these generic protocols. If we look at features and we go to scripting to see what we can go and run on the device, it's not included in precompiled binaries. You need to edit some C++ with some if-defs, kind of gross. If we look at supported devices, all supported devices, they've got a pretty good list of things here. But it's really going and taking something like, if I look for something Australian, here we go, there's a smart kettle. If I look at this, the configuration that it uses is this much more kind of opaque just line of stuff, which is really just going and declaring different GPIOs into different modes. And then you've got to do all these really low-level kind of API calls from Home Assistant still and MQTT results and all that kind of stuff. I think it's kind of gross versus the nice cleanliness of just being able to declare this is how my intercom works, and then you saw how well that instantly came up in the UI in Home Assistant. How do we put this onto other devices? Well, today I've shown you the M5 stack, I've shown you the ESP01 in a previous post. There's also stuff like the Shellys, which these can be put behind a light switch. So that kind of demo we just showed of having a button that controls a light locally, that's how you could have your light switch still physically switch to light, but also software controlled. And these devices here, this little black bit, that there is the programming header that you can plug into. So you can take this same type of firmware and just flash it straight onto one of those and it will come up in Home Assistant natively as well. So that was about 30 minutes end to end, minus a couple of edits that I will have stripped out in terms of where it was compiling and stuff like that, where we went from nothing to having an M5 stack, totally isolated from the computer, running on Wi-Fi with localized logic, going and doing rainbow effects on LEDs and all that kind of stuff. And we looked at how we could flash other types of devices, including more complex concepts like end-stop covers and things like that as pre-built ideas. So I think That's a pretty amazing mix of things that we can do without writing any code in less than half an hour. Have fun.